Hey, my name is Felipe and welcome to my channel. In this video, we are going to work with image classification and feature extraction. We are going to build an image classifier which internally uses feature extraction in order to classify images. This is a very advanced computer vision tutorial. And now, let's get started. And now let me show you the data we will be using in today's tutorial. Today we are going to work with the same weather dataset we already used in two of my previous videos. In my previous video where I show you how to train an image classifier using YOLO V8, and also in my previous video where I show you how to train an image classifier using Teachable Machine. Exactly the same weather dataset, and now let me show you super quickly how this dataset looks like. You can see we have 4 different categories, and these categories are cloudy, rain, shine, and sunrise. Now let me show you super quickly how each one of these categories looks like, and you can see that this is the cloudy category. Now if I show you the rain category, you can see we have many pictures of super rainy days. And if I show you the shine category, this is how the images look like. And if I show you the sunrise category, you can see we have many pictures of sunrises. So this is the data we will be using in this tutorial, and you can see we have 2 directories. One of them is train, and this is where the training data is located, and then we have another directory which is called val, and this is the validation data. Now let me show you something else. If I go to my browser, this is the GitHub repository we are going to use as a feature extractor, because remember, in this tutorial we are going to work with image classification, but we're also going to work with feature extraction, and this is exactly how we are going to extract features from our images. This repository is called image2vec with PyTorch, and this repository is available as a Python package. So this is exactly how we are going to extract features from our images, and this is the repository we are going to be using in this tutorial. Now let's go to PyCharm, because now it's time to start working on this tutorial. Now it's time to create a new PyCharm project. So I go to File, New Project, and I'm going to select the directory where I want to create this project, which in my case is something like here, tutorial. Okay, and I'm going to create this new project using a virtual environment and Python 3.8. I click on Create from existing sources, this window. The PyCharm project has been created, and now let's install the requirements we need in order to work on this tutorial. So I'm going to File, Settings, then Project, Python Interpreter. I'm going to click on this plus button, and the first library we are going to install is this one, right? We are going to work with this repository, so we are going to install this Python package. So we need to install image2vec / PyTorch. So let's find this library, image2vec, and this is the one we need, PyTorch. Okay, I'm going to click here and then install package. And that's pretty much all. Then we also need to install 2 additional libraries. One of them is scikit-learn. So I'm going to search for scikit-learn. This one over here. I'm going to press install package. And then I also need to install plow. And that's pretty much all. So my Python packages are being installed, but in the meanwhile, let's start working in this tutorial. Let's start working on all the coding of this tutorial. So I'm going to press here on OK, and then I am going to create a new file which is main.py. main.py. Okay, and this is the file we are going to use in order to train our image classifier, in order to do the feature extraction and also the image classification. So I am going to enlarge it a little, and the first thing I'm going to do is to write the 4 steps we will take in order to complete this process. The first one is to prepare the data we are going to use in order to train this classifier. Then we are going to train the model, we are going to train a classifier, then we are going to test the performance of this classifier, and finally we are going to save the model into our computer, right? So these are the 4 steps of today's tutorial, and now let's get started. And the first thing we need to do is to import from image2vec PyTorch import image2vec. Okay, and then we are going to create image2vec, we are going to create a new object, which will be the feature extractor we are going to use in order to extract features from our images. And now let's prepare the data. So I am going to define a new variable, which is data directory. And this is the directory where my data is located. And my data is located in the current directory. This is the directory where I have created this project. This is the main.py file in which we are currently working in. And this is where my data is located. It's in a directory which is called data. And within this directory, there's another directory which is called weather dataset. So I am going to define the data dir as data weather dataset. Then let's create two additional variables. One of them will be train directory. And this is where my training data is located, which is here. Let's do something more like this. ospath join data directory and then train. Okay. And then the validation directory, which is going to be something like this. Okay. And I need to import OS, otherwise this is not going to work. So import OS. Okay. And that's pretty much all. Remember, within weather dataset we have two directories. One of them is called train and the other one is called val. Now let's continue. Now let's walk through all the files in these two directories. And this is how we're going to do. For dir in train directory, val directory, for category in os list dir directory, right? We are going to iterate in each one of these categories. And we are going to define another variable. We are going to make another loop, which will be for image path in os list dir os path join dir category, right? So we are iterating in all the images which are within this directory, right? So we are iterating in all the categories. So we are iterating in each one of these 4 directories you have over here. And then for each one of these directories, we are going to iterate in all the images you can see over here, right? Now we are going to define another variable, which is going to be image path underscore, and this is os path join directory category and then image path. Okay. Then we are going to make another import, which is from pil import image, because we are going to read each one of these images. We are going to load each one of these images like this: image.open image path underscore, and this will be image. Okay. And now we are going to compute all the features from this image, and this is how we're going to do. We are going to call image2vec dot get vec, and we are going to input the image. And that's it. This is all it takes to compute all the features from this image, and this is going to be something like features. Okay. Now I am going to create 2 lists. I'm going to do it over here. One of them will be features and the other one will be labels. Okay. And this object, maybe it's a better idea to call it something like image features, right? Something like that. And now we are going to append features.append image features, right? And then labels.append, and the label will be something like the category, right? These are our labels. Each one of these directory names is our categories, right? These are all 4 categories. So in order to append the label, we need to append the directory name. We need to append this variable over here, which is called category. Now let's continue. Now I'm going to define another variable, which is data. This is going to be a dictionary. And I'm going to do something like this. I am going to walk not only in the directories, but I'm also going to define another variable, which is going to be jdir in enumerate train dir, val dir, something like this. So now this is going to take these two values. Dir is going to be train dir in the first iteration, and it's going to be val dir in the second iteration. And j will be 0 in the first iteration, and it will be 1 in the second iteration. So by doing so, we can do something like this. Now I'm going to say data, training data, validation data, and this will be j equal to features, and then the same but with the labels, training labels, validation labels, j, and this will be labels, right? Remember that in the first iteration, dir is training directory and j will be 0. So if we access the index number 0 from this list, we are going to get training data. And then in the second iteration, j will be 1. So we are going to access the second element, which is validation data. So we are going to create this key according to the iteration we are in. And the same is going to happen for the labels, right? But in order to be more clear, let me show you exactly how this variable we have over here, how this dictionary we have over here, how it looks like. So I'm just going to execute the code as it is, and at the end I'm going to say something like print data.keys, right? Let's take a look at this dictionary we have over here, and let's see exactly how it looks like. Let's see exactly what are the keys for this dictionary. So I'm just going to press play. Okay, the execution is now completed, and these are the keys we have saved in this dictionary: training data, training labels, validation data, validation labels. So I invite you to take a look at this code. I invite you to go through this code once and again until it's 100% clear for you exactly what we are doing over here. Please notice we are iterating in all the images, in all the training images and all the validation images. We are opening these images, we are computing the features, and then we are saving this data into these two lists we have over here, and then we are saving these lists in this dictionary under these very appropriate keys, right? So please go through this code once and again until it's 100% clear for you. But for now, let's continue. We have saved all of our data into this dictionary, and now it's time to train the model. And in order to train this model, let's go to my browser super quickly, because we are going to use a model, a classifier from scikit-learn. And let me show you all the different classifiers we could use from scikit-learn. I also invite you to take a very close look to this website so you are more familiar with all the different classifiers you could use from scikit-learn. In this tutorial, we are going to use random forest classifier. We're going to use this classifier over here, but we could also use any other classifier from here, right? The only reason we are going to use a random forest classifier is because I like it. I really like this classifier. I have used it many times in many projects. I think it's very robust. It's very easy to use. It's very easy to understand what's going on. I really like this classifier, but that's the only reason why we are going to use a random forest classifier. We could also use any other classifier from here. So let's go back to PyCharm, and now I'm going to make another import, which is from sklearn.ensemble import random forest classifier, and then I am going to take this value random forest classifier, and I'm going to define another variable which is called model, and model will be random forest classifier, right? We are creating a new instance of this classifier. And then in order to train the model, the only thing we need to do is to call model.feed. We need to input the training data, which is here. The training labels, which are here. And that's it. That's all. That's all it takes in order to train this classifier. You can see how simple this is. Now let's continue. Now it's time to test the performance of the image classifier we have just trained. And in order to do so, I am going to make another import, which is from sklearn.metrics import accuracy score. And I'm going to make something like this. Model.predict validation data. Data validation data. We want to access our validation data, which is saved here. And this will be something like ypred. Then we are going to call accuracy score. We're going to input ypred, and we're also going to input data validation labels. Okay, so you can see we are computing the accuracy score with the validation data, which is completely and absolutely unseen data for our model, for our classifier. You can see here we are training our classifier with the training data. The validation data is completely unseen data. The classifier has never seen this data before. So this is exactly the type of data we should use in order to compute the accuracy score and in order to test the performance of our model. So this is going to be something like score. And now I am going to print score. And then we are going to say the model. But let's take it one step at a time. Let's execute this script. Let's see if everything is okay. Okay, the execution is now completed. We didn't have any error whatsoever. And this is the accuracy we got. A 94.4% accuracy, which is a very, very, very high level of accuracy. Now remember, I told you this is exactly the same dataset we used in 2 of my previous videos. In my previous video where I show you how to train an image classifier using YOLO V8, and also my previous video where I show you how to train an image classifier using Teachable Machine. This is exactly the same dataset, so I invite you to take a look at those 2 videos and to compare the accuracy we are getting here with this classifier with the accuracy we got in those 2 videos, right? Using YOLO V8 and using Teachable Machine. I invite you to compare this accuracy with the accuracy we got in those 2 other videos. That's your homework. That's your homework from today's tutorial, and now let's continue. So the only thing we need to do now is to continue to the next step, which is saving the model. And this is how we're going to save the model. We are going to import another library, which is pickle. And we are going to say something like this. With open, the file name will be something like model.p. This will be wb as f, and we are going to call pickle.dump. Then this will be the object we are going to save, which in our case is model, and then f. And that's pretty much all. Then I'm going to close the file. And now I'm going to run this file again. Okay, and now if we go to my file system, you can see that now we will have a file which is called model.p, and this is the model we have just saved. So everything is working just fine. And now let me show you how to take this model, how to load this model to produce inferences with it, right? So I'm going back to PyCharm and I'm going to create a new file which is called infer.py. And this is where we are going to make our inference. So I am going to take a few lines from here. I am going to import this object, and I'm also going to import this other object from peel. And then this is going to be a very, very similar process. I'm going to create this object over here, which is image2vec. This is the object we are going to use in order to compute our features. And then I'm just going to define an image path, which will be one of my images in the validation data. I'm just going to take a random image, something like this. cloudy4.jpg, a random image in this directory, and then I am going to do something like image will be image.open image path, and then I am going to compute features from this image, doing something like image to back dot get back image. This will be features. Okay, then I am going to load the model, or maybe I can load the model over here. So I'm going to say something like with open model.p, this will be rb as f, and model will be pickle.load f, and obviously we need to import pickle, otherwise this is not going to work. Import pickle, and that's pretty much all. And now we are going to call model.predict, and we are going to input the features, and this is how we are going to do it. And this will be something like prediction. Okay, and now let's print prediction and let's see what happens. And this is the result. We are getting cloudy, which is exactly this image category. Remember, we are taking this image from the cloudy directory, and absolutely all the images in this directory belong to the cloudy category. So everything seems to be working just fine. And this is going to be all for this video. My name is Felipe, I'm a computer vision engineer. If you enjoyed this video, I invite you to click the like button, and I also invite you to subscribe to my channel. This is going to be all for today, and see you on my next video.